Okay, we're going to look at something called condition for tangency. Okay, so this is within the context of quadratic theory. Okay, now, first of all, if you think about a quadratic equation that's got two roots, okay, so what do we say there? That the discriminant is greater than 0, as you know that from National 5. When it's just got one root, the discriminant is equal to 0, and when it doesn't have any roots, then the discriminant is less than 0. Now you can see in this case, when the discriminant is equal to 0, we can say that the x-axis there behaves as a tangent to the curve, so you can see that. So a tangent's being one point of contact, and if you think about a tangent to a circle, that's also when it has one point of contact. And with no points of contact, it's less than 0, and with 2 points of contact, that's when it's greater than 0. Now we can apply the same logic and the same thinking to quadratic theory with not just curves in the x-axis, but curves in different types of straight lines. Remember that the x-axis is just a straight line. Okay, so take note of this. When you've got no points of contact, we would find the discriminant to be less than 0. When it's 1 point of contact, we would find the discriminant to be equal to 0. And when it's 2 points of contact, then the discriminant to be greater than 0. Okay, so let's put this into action with a couple of examples then. Okay, example 1, we're going to prove that the line y equals 2x minus 1 as a tangent to the parabola y equals x squared, and we're also going to find the point of contact. So I'm going to call that POC. Okay, now my first move is I need to make the functions equal to each other. Okay, now what was that all about? Well, if you think, if you've got a curve and you've got a straight line, well, at the point of contact, their y coordinates are equal at that point. So what we'd say is y the straight line will be equal to y the parabola. And then I'm going to just bring everything across and make equal to 0, so that would be x squared minus 2x plus 1 is equal to 0. I can then factorise, two numbers multiply, give 1 together, give minus 2 is minus 1 minus 1. So I get x minus 1 all squared is equal to 0, and that will give me an x coordinate at the point of contact of 1. Okay, so let's prove tangency. We prove tangency by going after the discriminant, so we can see that a is 1, b is minus 2, c is 1. So a is 1, b is minus 2, and c is 1. b squared minus 4ac minus 2 all squared minus 4 times 1 times 1. That's 4 minus 4 equals 0. d equals 0. Therefore, tangency exists. Okay, so that's that scenario in which we only get the 1 point of contact, and we've proved the tangent, the discriminant is equal to 0, therefore it's a tangent. Okay, so we've got x coordinate at the point of contact, so how do we get the y coordinate? Well, we'll just sub it into an equation that starts with y. I've got y the straight line or y the parabola, doesn't matter, just choose one. So we're going to sub x equals 1 into y equals x squared. I would get the same result if I put into y equals 2s minus 1, so it's going to be 1 squared, and that is 1. And that will give me my point of contact, then the point of contact is 1, 1. Okay, let's just spend a bit of time reviewing this question. So you need to prove that tangency exists. So ultimately tangency exists if I can get the discriminant to be equal to 0, and you prove that. What do I first of all do? Make the functions equal to each other. We sometimes call that making y equal to y. Now, why is that a valid thing to do? Well, if you think about at a point of contact, where a straight line and a curve or any two functions are, at the point of contact, what you can say is that their y coordinates are equal. So we make y the parabola equal to y the straight line. We then bring the thing across and make it equal to 0. So that was x squared minus 2x plus 1 is equal to 0. Factorise it to get x equals 1 from the point of contact. I then identify A, B and C and put that into discriminant. I calculated that to be 0, which means the tangency exists. I then get the x coordinate and sub it back into one of the equations for y. It doesn't matter which one because I'll get the same result, and that will give me my point of contact, which is 1, 1. Okay, let's try an example 2. Okay, so we're going to prove tangency and find the point of contact again. And this time I'm given y plus 8x plus 8 is equal to 0, and the parabola is 2x squared. Okay, so what's my first move? Oh, my first move is make y equal to y. Okay, so I'm going to go ahead and write that. Now, you might at that point think, well, I don't have that as y equals, but that's fine, you know how to deal with that, just change the subject of the formula. So that will be y equals minus x minus 8. I can then make y equal to y, 2x squared equals minus 8x minus 8. I then bring the thing across and make it equal to 0. 2x squared plus 8x plus 8 is equal to 0. Remember, the first rule of factorising is to take out a common factor, so that's 2 bracket x squared plus 4x plus 4 is equal to 0. Two numbers are multiplied give 4, add together give 4 is 2, so that's a squared bracket of 2. And from that I'll get x equals minus 2. Let's now go after the discriminant. A is 2, B is 8, C is 8. Okay, so A is 2, B is 8, and C is 8, and that goes into B squared minus 4AC. So it's going to be 8 squared minus 4 times 2 times 8, and that's 64 minus 64, which is equal to 0. That's the result I was looking for. D equals 0, therefore tangency exists. Okay, point of contact, well, I've got the x coordinate, and how to get the y coordinate for the point of contact, put it into an equation for y. So I've got that one, or I've got that one, doesn't matter. So just sub it into one, you'll get the right result. So I'm going to sub x equals minus 2 into y equals minus 8x minus 8. Okay, so that's y equals minus 8 bracket minus 2 minus 8. That's 16 minus 8, and that is 8. So my point of contact then, x coordinate is minus 2, and the y coordinate is 8. Final answer. Okay, now at the end of this exercise, I'm not going to give you questions to do, but just to tell you that for tomorrow, exercise 8J, that will answer question 1. That's how you do question 1. Let's move on to another couple of examples. Okay, example 3, this one's a wee bit different. We're going to find the equation of the tangent. To y equals x squared plus 1 that has gradient 2. Okay, now first of all, we're asked to find the equation of a tangent. Now, what's a tangent? A tangent is a straight line. It's a specific type of straight line, but first and foremost, it is a straight line. So what do I need? I need gradient and point, and I'm going to put that into y minus b equals m bracket x minus a, and that will do the job. Now, what do I already have? I already have the gradient. It tells me that the gradient is 2, so that then means I need to go after the point. Okay, so let's see how we're going to go about this one. Okay, tangency exists. So I'm going to first of all make y equal to y. That's the first thing. So it's going to be x squared plus 1 is equal to the straight line. Now, what I know is that this straight line has a gradient of 2, but what it doesn't tell me is the y-intercept. So what I could say generically there is I could say, right, if the gradient is 2, then that's y equals 2x. Now, if I don't know the y-intercept, well, if I don't know it, I don't know it, just call it c then. So what I could say is, generically speaking, this equation has got the equation 2x plus c. So the gradient is 2 and the y-intercept at the moment is unknown. So just call it y equals 2x plus c. You'll actually find that we'll make some progress by doing that and then make y equal to y. So there's y the parabola equals y the straight line. Do the same as before, bring the thing across and make it equal to 0. So it's going to be x squared minus 2x plus 1 minus c is equal to 0. Let's identify a, b and c. A as 1, b as minus 2. Now c is, it's not 1, it's everything else. Okay, so a is the coefficient of x squared, 1, b is the coefficient of x minus 2, c is everything else, which is 1 minus c. Now just to cut down a bit of confusion here, what I should maybe do is call that something different, maybe call it k. Okay, just so that it's not too confusing. Okay, 1 minus k. Okay, so b squared minus 4ac. Now what I'm going to immediately say is that that's equal to 0, and how do I know that? Because it's a tangent, so I know that the discriminant is definitely equal to 0. Okay, so it's going to be minus 2 squared minus 4 times a, which is 1, times c, which is 1 minus k, and I know that that is equal to 0. That's then 4 minus 4 bracket 1 minus k equals 0. 4 minus 4 plus 4k is equal to 0. They two cancel out, and I've just got 4k is equal to 0, which means k is equal to 0. So for the equation of the straight line, then its gradient is 2 and its y-intercept k is 0, so that's just y equals 2x, final answer. Okay, so let's just spend a bit of time summarising this question. Okay, first of all, the question said find the equation of the tangent to the parabola y equals x squared plus 1 that has gradient 2. Okay, so the first thing is I don't know the y-intercept, so the y-intercept, which I'm calling k there, I don't know. So generically speaking, the thing can be written as y equals 2x plus k. Okay, so the next thing that I do then is I make y equal to y the parabola is equal to y the straight line. And again, I'll change that to k. Okay, I then bring everything across, make it equal to 0, so it's going to be x squared minus 2x plus 1 minus k is equal to 0. And then it's a equals 1, b equals minus 2, and c equals 1 minus k. The discriminant is equal to 0, I know that because tangency exists. So that's going to be b squared minus 2 squared minus 4 times a, which is 1 times c, which is 1 minus k. Feed that all in. Do the discriminant and you get the value for k. Once you've got the value for k, you know the value for the gradient is 2. It's y equals 2x plus 0, and that's y equals 2x. Now that should now help you out with exercise 8j and questions 2 and 3. So just to be clear, I'm not asking you to do that just now. That's going to be for tomorrow. But that example will help you out with 2 and 3, so it'll be worth taking a note of that just now. Okay, let's try one final example. Okay, so example 4. Find the equations, that's plural, find the equations of the tangents from 0 minus 2 to the curve y equals 8x squared. Okay, now we've almost got a kind of opposite scenario here. This time that you're told that you've got tangents that come from minus 2. So what we've been provided with this time is not the gradient but the y-intercept. So generically speaking, what I could say now is instead of y equals mx plus k, well, instead of knowing the gradient, not knowing the y-intercept, it turns out this time that I do know the y-intercept, that's minus 2, and it's the gradient that I don't know. So generically speaking, I can now write that one as y equals 8x minus 2, and then I start to follow this pattern, make y equal to y. Okay, so y the parabola is equal to y the straight line. Okay, I'm talking about tangency, so b squared minus 4ac is equal to 0 for tangency. I'm going to go ahead and state that. It will then be ax squared minus mx plus 2 is equal to 0. And then it's a equals 8, b equals minus m, and C equals 2, and feed that into the discriminant. So it's going to be minus m squared minus 4 times 8 times 2 is equal to 0. M squared minus 4 times 8 is 32 times that by 2 is 64 is equal to 0. We'll then get m squared equals 8, and m is going to be equal to, or m squared equals 64 rather. M equals the square root of 64, and that's going to be plus or minus 8. So the gradient is either going to be 8 or minus 8. My y-intercept in both situations is minus 2, so that's y equals 8x minus 2, or y equals minus 8x minus 2. Final answer. Okay, now what will be useful for tomorrow is just spend a good amount of time summarising through those questions, those 4 examples, so that you're ready to pick that up immediately coming in tomorrow.